my pleasure to introduce Dr. Tangchaitrakul, the Deputy Director General of the Department of Highways, who will deliver the opening remarks for our Smart Mobility Workshop. Please join me in welcoming Dr. Tangchaitrakul.
Good morning, ladies and gentlemen. Welcome everyone, and many thanks to you all for taking the time to join the workshop on smart mobility this morning. To open the workshop, I would like to give a brief of the extent to which smart mobility is a crucial need for urban cities in Asia and practical challenges to be addressed for its successful implementation. Asia is the fastest growing economy region and has experienced significant demographic change over the past half century. With a population of around 4.8 billion people, the Asia region is home to about 60% of the world's inhabitants. According to statistics and estimation reported by Asian Development Bank, the Asia region accounts for around 37% of global GDP, which is expected to rise to around 42% by 2050. At the same time, the region's urban population has expanded to more than 2.2 billion people, with a projection for an additional 1.2 billion people in urban areas by 2050. Cities in Asia are at the global forefront of economic opportunity and in efforts to secure a more sustainable future. While the quality and efficiencies of urban areas would determine Asia's long-term competitiveness, the primary appeal of greater urban opportunities and accumulation benefits would be substantially weakened by social, economics, and environmental pressures associated with rising urban populations. For many countries, the boost to economic growth from transport are also prioritized over its severe traffic problems and increasing urban inequality. Various attempts have been made to address such concerns and provide cost-effectiveness transport options across the region through smart transport system. The demand for cutting-edge technology to improve traffic operations, enhance urban traffic flows, and increase the city livability has been increasing. Smart mobility promises more efficient, sustainable, and convenient transportation for individuals and societies through the use of advanced technology. This innovative concept opens up new exciting prospects and is gaining interest from industry stakeholders, policymakers, and general public. However, smart mobility faces several challenges in its implementation and widespread adoption. Establishing adequate infrastructure for smart mobility can be a significant challenge. The technology used can be costly to develop, deploy, and maintain. For smart mobility to be fully effective, the new transportation solution need to be accepted by people, as they might require individuals to change their travel habits and embrace new technologies. Moreover, existing regulation and enforcement may not be suited for smart mobility. It is important to establish a flexible and evolving regulatory framework to accommodate the integration of this new technology. As many technologies for smart mobility rely on the collection of massive amount of personal data, which raise privacy concerns, implementing security and privacy measures is therefore crucial to protect user personal data. Finally, smart mobility should be accessible to all individuals, regardless of their socioeconomic status or geographical location. Otherwise, it will create disparities and inequalities in access to technology and transportation services. Today, we have gathered an impressive lineup of speakers who will be sharing their expertise and hands-on experience on smart mobility. including the implementation of free-flow tolling system for motorway, the integration of intelligent transportation system for smart highways, as well as the vision and perspective on artificial intelligence and 5G technology to drive the smart mobility solution for green and smart cities in the future. Ladies and gentlemen, I hope you all will enjoy the presentation in this workshop and get insight into the future trends and opportunities of smart mobility in road transport for Asia and beyond. Thank you very much.
Thank you, Dr. Piapong, for those inspiring and insightful remarks. Dr. Agachai Sumalee, a professor at Chulalongkorn School of Integrated Innovation. Dr. Agachai is also an M-Flow advocate and play a key role in introducing this project to Thailand. Today, he will be discussing the M-Flow technology platform solution for the first Thailand free-flow tolling. So let's welcome again to Dr. Agachai.
Thanks a lot. Good morning, everyone. So first of all, I have to thank FETC, Kenny, for inviting me, and also the DOH for organizing such an impressive exhibition and also conference. So what I'm going to explain today is a part of the information about the implementation of the free-flow tolling in Thailand. And I think I saw a lot of familiar faces today that actually help thinking and also designing. So I'm just a representative, okay, to tell you the story that we've been through. So first, I think the M-Flow, I think as you know, is actually multi-lane free-flow tolling. So a form of tolling system for any toll road. The particular thing about the design of M-Flow in Thailand was the way that we decided to use the technology to do number plate recognition, okay, of the vehicles to identify them and then apply the appropriate toll charge. And that's helped for the dissemination in terms of the accounting and user registration in the first period of the implementation of such a tolling system. And the payment system for the M-Flow in Thailand is a post-pay, so you can actually use the toll road first and then you pay later through the different payment channel system. And the location that we implement the free-flow tolling is on the motorway network on the M number 9, okay, motorway number 9. In Thailand, we love to use a number system to make it simple. And this is the 4 different toll plaza that we implement this free-flow tolling. So you can see the alignment, that this is the alignment for the current, okay, toll plaza, and then the dedicated right-of-way for the M-Flow tolling system. So here at the different toll plaza, the number of lanes that are currently under the operation for the MTC is a manual toll collection, okay, 8 lanes, and then we have the legacy system of the electronic toll charging system, ETC, which is M-Pass, Easy Pass. Like this location here is 2 lanes, and the M-Flow is a 5 lane over here. So you can see a different variation of the design, and the next speaker will give you also Dr. Thanasak, the director of Motorway. He has more detail on this type of design. What I'm going to focus today is on the technology design. It's a bit like, imagine any country who would like to rush to implement this type of system. We have, short amount of time to make the thinking and the design. But another important thing that we learn and also we put in the design is that the importance of the overall system design, what we call the single platform. Okay, because we learned from the past in Thailand is that when we have such a project that we rush to use technology, and later on when we have another deployment at a different location, if the architecture wasn't put in place beforehand to allow those new toll roads to be integrated, right, to the existing accounting system, existing validation system, that would be quite troublesome for the user and also for the operator. So the M-Flow overall architecture design so that each of the routes have their own transaction elements that interact with either is an open toll road system or the closed toll road system, and then it interact with another layer, what we call the auditing system, and that's to make sure that all the transaction has been verified and the toll is collected. And then the main component of this architecture is this single platform here that handle the user registration and the transaction validation, the billing system, reconciliation of the payment, and also the other type of elements. And the external interface of this M-Flow system have the interface with the relevant department, government department agency, like the Department of Land Transport, in terms of the vehicle registration data, from the Interior Ministry for the user identification in terms of their citizen identification detail, and also with the different banking payment. So this is like the overall design that when we actually deploy the project, normally we focus on this bit when we talk about the technology bit, which is also important. But the overall architecture that allow additional route or additional link, okay, to be added into the single platform is also as important. The design was also allow for other party to join in terms of the toll operator, not only the DOH. DOH is a Department of Highway, but actually in Thailand there are other toll operators actually beyond the DOH responsibility. I will touch on that later on as well. So the first bit here is each of the like a toll road will have the transaction generation, and that will come from the toll lane equipment system. And then we'll pass on the raw data. I'll say here is a raw data in terms of the transaction for each of the location and the time period, okay, under the DOH audit standard. And the transaction detail will then be verified and also passed on in terms of transaction, the billing, payment, reconciliation detail to the single platform, okay. For this lane gantry equipment, for that transaction generation, there is a standard equipment, including, of course, the CCTV camera, okay, the ALPR camera, the LiDAR detector, the flash for the camera system. Even though the main identification of vehicle in M-Flow is a number plate, right? But actually, to supplement the accuracy of identification, we also decide to be able to identify the vehicle by the RFID, okay, tag that been deploying, okay, to the vehicle as well. The typical layout of the gantry, then you have a different lane, okay, and the system will cover not only the lane itself, but also the lateral movement across the lane, okay. So this is just a basic standard. So the design of that architecture is that regardless of what is your lane equipment, the basic information that create the transaction detail of each vehicle, okay, we have the standard list of information that should pass on to the single platform. So the billing will happen at the single platform, but so toll operator can basically choose their own solution basically, okay, without any type of constraint or anything, as long as the basic requirement of the data format and in terms of the requirement to make the transaction detail is sufficient. So for example, for each of lane control system, you can send in the data, and what's going to happen is like in the transaction management system will verify the vehicle information, okay, the number plate, everything, and also we'll analyze the number by the ALPR, automatic license plate recognition. But to make sure that actually sometimes it happens that AI or the image processing unit may not confidently identify the number, okay, because Thailand also have a quite unique numbering system. So the manual license plate sort of like verification here also introduced to verify the number plate identification that may not be accurate or have some uncertainty in terms of the recognition data. And then after this verification process, then the information on the trip has been sent to the back-end system of M-Flow, and that's where the transaction detail and the payment and billing is actually occur. So what I mentioned is that the challenge we have is basically like normally when you have the AI for recognizing the number, in the past we typically rely on the OCR, right? The object in terms of the text identification. But the challenge in Thailand is like, first of all, the provincial letter is quite small, okay? Second, we do have like a, with different range of the like types of number plate. So if you come to Thailand like 2-3 years ago, the main type something looked like this, and maybe you can see some of these a little bit more expensive type of license plate that we put out for the auction. But in the past 2-3 years, we have a new type of license, which is like you can define your own words, okay, in the number plate. So you can put your own name basically, as long as the number of character is within the limit. So this is the challenge that actually I think sort of like you need some manual verification, and then later on that data can be introduced back to improve the accuracy of the AI verification. Another challenge in Thailand case is this we call the red plate, red license plate, when you have a new vehicle coming out from the factory, and then the user so eagerly would like to use the vehicle. Before they get the official registration, they tend to receive this, what we call the red license plate registration. And because it's not the permanent yet, so there's a lot of fake license plate, and that's another challenge in the M-Flow system that we need to identify as well. So another subsystem that I think we introduced, and then because in Thailand, when we design this system, the requirement is not only from the technical perspective. We have a lot of requirement from legislation framework, from financial disciplinary act, okay? I think in some country we say that if the toll leakage is within like 0.5% or 1% is acceptable. But then in Thailand, in terms of the DOH and the system that belong to the government, basically it's unacceptable. Even like a 1 baht is missing is unacceptable. So another thing that the M-Flow system design is a lot of legislation framework, and that's something that I think Dr. Thanasak will mention. But then the other part that we introduce in the design is this, what we call the audit system. So to make sure that first of all, the transaction that actually create at the gantry has been double verified in terms of the number. Second, the verification of the vehicle classification has been verified, okay? So the design is that like the raw data that come from the M4 gantry is transmitted directly to the audit system. But on top of that, we also have additional data from the set of parallel independent set of equipment that allow us to use that to verify it. And these two set of data will be verified on the audit platform. And this process is not double work, but actually only something that actually abnormal in terms of a total quantity, okay, will be get a look into the detail in terms of the verification of this audit platform. So compared to the main M-Flow solution, then the audit system will be much simpler. So just basically some context camera, and then the laser system that verify the counting, and then have some like high-speed camera for verification of the vehicle type, and also we have this double laser sensor, another one for look at the vehicle profile to help with the classification as well. So over the time, in the chain of the data between the main M-Flow and the M-Flow audit just help each other in terms of the minimizing the loss and minimizing the wrong tolling. The figure may look a bit high, but I have to say that actually it's not that high in terms of the percentage, because each day we have a lot of transaction, okay, per location, and then the audit sort of like, if you like in the football team, is like the last defender of the system, and that help to correct in terms of the classification and also in terms of the charging the toll amount is in average about 1 to 2%. But again, the main solution that we have should be okay for any application, for any implementation. But again, as I say, in Thailand, our legislation bar is very high. So when you have external organization to come in to ask you for how do you make sure that the money is accurately told and also accurately collected, then I think the architecture that we put in place here help to answer those type of questions. And that's the part that send the data all back to this mFlow single platform. Okay, and then as I say, that handle with the registration of the vehicle, transaction validation, the billing through the application and to other source of communication, and also to reconcile the payment, the financial transaction we get from the user and get for the different payment platform. So when we decide this, the challenge that we have, I think, over time, you start to have the different toll operator, and also you start to have the different road segment. So the standard that the mFlow single platforms develop now is the set of API, okay, the API standard that help to identify a different set of data that need to communicate from different part of architecture I mentioned in the previous slide. So we have like a 5 different set of API here, A, B, C, D, E. So basically the A part is basically the API for the data transaction between mFlow and the single platform. So if you're a toll operator in Thailand, like, you know, different route segment now, not only the DOH own operation, but maybe like the concession or anything, then you basically understand that you can carry out this transaction by yourself, by your own technology. So as long as a set of data that you need to send to the API specification for the mFlow transaction and also the single platform for the A segment here is carried out. So this one is trip entry exit, okay? And then B is between the mFlow and the auditing system. So like I mentioned, apart from the main tolling equipment, to ensure that the data integration, the data qualification at this location here is not like change or anything, and also the number of vehicle detected and the classification is verified and adjusted if necessary. Then this is a API specification for the mFlow and the audit system over here. Okay, so you can see that this doesn't go through the single platform yet, so it's really verified at the raw data level. And then the single platform and the auditing system to receive back the information for the trip payment and also any type of financial transaction. So the audit not only include the vehicle classification and vehicle number verification, but also the payment, that all the single detail of each transaction has been verified. And we also have the API spec for the single platform and also the auditing system and also single platform and the fitment center. So as I mentioned, there is a fitment center for RFID tag. So not only the number plate recognition that we use for identification of vehicle, RFID can also be equipped to the vehicle if required, and that help in terms of the identification as well. So I think now is about 2.5 years, okay, after the opening of the mFlow first operation. If I remember correctly, it's a Valentine 14th of February, 2022, okay. It's a Valentine Day, okay. So both our distinguished guests here is on the road, so trying to make sure nothing gone wrong, okay. So now the penetration rate of mFlow user is, I think, almost 50%. Compared to all the trips that make across these 4 toll plaza that we have. And but still, from time to time, we do have the question like why those who are not using mFlow, they do not switch to be the mFlow user. So some of the feedback that I think quite interesting is like we have this set of feedback from the different persona of the group who are the member and also the non-member who are using the mFlow and also the non-user themselves. And I think, of course, the upside is like the system is designed to be very convenient and of course save time and fuel, and then no need for cash for payment, different payment channel that we offer to them. But the downside that I think we sort of trying to improve upon is in terms of the still some sort of like uncertainty in terms of the confidence of the public on the inaccuracy and also the delay of the payment system, and some is concerned over the system security, okay, and then they concerned about the fine themselves because they forget to pay, and then from time to time I receive like oh, Ajahn, I forgot to pay. What should I do? Then I say, just pay the fine because I just pay as well. So, but then I think this is something that we can take a look on how to reduce this anxiety, okay, in terms of, to get the fine. Some of the users are interesting is that basically they are the business user or the vehicle doesn't belong to themselves. So this procedure not align with the company policy. And then the last but not least, some more contact information. I think it's just a typical point that I think when we launch such a new system, then, people demand more and more, become more and more accessible, more and more convenient. But I think in overall, I think we have a very solid architecture that can extend to different operator, to different route, and also the system that can basically quite easily to handle all these further improvement that we can have. So I think that's the end of my presentation. So thanks for your attention, and if you have any question, then please feel free. Thanks a lot. Thank you.
Dr. Thanasak Wongtanakitcharun, Director of Intercity Motorway Division from Department of Highways, who oversee the M-Flow project in Thailand. Today, he will be discussing the challenges and lessons learned of Thailand's first free-flow tolling system. Let's welcome Dr. Thanasak.
Sawadee. Good morning, distinguished guests and ladies and gentlemen. Welcome to the 5th International Workshop. This is the biggest event conducted by Department of Highway, and I'm so honored to be here and this opportunity to give and share experience for the use of AI application for the first barrier-free or multi-lane free-flow tolling system in Thailand. All right, I am the director of Intercity Motorway. Actually, our job is to operate and give the best quality service to the motorway user. So one of our goals is to provide the best service to motorway user, and one of the challenging tasks is to solve the traffic congestion in front of the toll gates. And as you can see that, let me see. Which one? This one. Nope. I have to do this. Okay. The challenging task of motorway is that because we have been operating motorway for more than 26 years. We first opened motorway since 1998, 26 years ago. All right. And imagine 26 years ago, could you please guess the number of vehicles passing through the toll gate 26 years ago? So how many vehicles passing through the toll gates every day? 26 years ago, only 30,000 vehicles using motorway passing through the toll gate. All right, and could you please guess the number of vehicles using motorway nowadays? Can you give a good guess? How many vehicles passing through the toll gate today? I would say that the average number of vehicles passing through the toll gate is now more than 650,000 vehicles per day passing off the toll gate on motorway number 7 and on motorway number 9. All right, that's very rapidly increasing in the number of vehicles passing through the toll gate. So originally, the toll system that we use in order to collect the money and everything, we use the manual toll collection. All right, and then when the number of vehicles increase, what we do is that we just increase the number of booths. But at some certain point, we cannot increase the number of booths anymore. So that's why 10 years ago, actually Dr. Agachai also part of the team to study for the master plan for toll collection system development plan 10 years ago, starting from 2015. So we start with the vision, the strategy to solve for the traffic congestion in front of the toll gate. So we come up with this master plan. All right, let me just show you. All right, so this is the master plan of how we plan to develop the toll collection system for motorway 10 years ago. All right, starting from we use the manual toll collection. All right, and then to enhance the efficiency and road safety, so we come up with the electronic toll collection. Like 10 years ago, we start to use the DSRC technology. This is what we call impasse. All right, we start from 2015, and as you can see that, and the impasse, like we use this system for more than 10 years, and we have a lot of pain points. And you can see that right now, after we operate this system for more than 10 years impasse, all right, you can guess what is the proportion of the people using impasse compared to the overall trip. All right, so after 10 years, all right, the number of people using impasse, easy pass, only 30% of the overall trips. 10 years. All right, 70% using the manual toll collection and 30% using the impasse, easy pass, because we got a lot of pain points. For example, the system of impasse, easy pass, people need to transfer the money first before going to pass the toll gate. And then if the money is not enough, the barrier will not open, and it will cause a lot of traffic jam, especially for the rush hour. All right, so that's why we have this master plan 10 years ago. So the vision is that we are trying to first solve the problem using the electronic toll collection technology, all right, to improve the accuracy, to increase more capability in order to like alleviate the traffic. All right, so we start from manual toll collection, electronic toll collection, and using single and free flow. And the final goal is that we are trying to use or deploy the multi-lane free flow. That is our goal, 10 years plan. And today, just good news that we can do it. All right, we can launch the multi-lane free flow, the first multi-lane free flow in Thailand 2.5 years ago, as Dr. Agachai mentioned about that. But actually there are a lot of challenges. There are a lot of like change, because when you change the application, you change the process, all right? Because people normally like familiar with the old system, because they just familiar with like for cash payment, they just need to like just stop by at the toll booth and then pay for the money and then get change and then they go, right? And for the impasse, easy pass, they have to transfer to money to the DSRC or to the tag first, all right, and then go to the toll gate, all right, and then the barrier open. But for modern P4, all right, we use the high technology in order to capture the license plate, all right, and the motorway user will not need to stop at the toll plaza. They just like go and pass, and then they just come back to pay for the toll fee within the certain time that we allow them to pay, all right? So that's changed a lot. And then the problem is that the challenge is this. Actually, there are 3 key factors for the success story of inflow. The first one is the technology, all right? So before we launch we launched the new system, all right, M4, and then we are first collaborate and study, review every technology from all around the world, all right? You can see that we just review the tolling system from Europe, Canada, US, and also from Asia, like Taiwan, Australia, and so on, all right? So we have to make sure that technology will be suitable for the use of multi-lane P4 in Thailand, all right? So we study a lot about the technologies, all right? And as Dr. Agachai said, all right, for the technology, Motorways Division always welcome any new technology to improve the efficiencies and road safety. All right, but to do this, actually, as Dr. Agachai said, we have the single platform, which is the centralized system, which can connect to the new route, to the new operator. Our role, our motorway role is that we need to have the standard of inflow, all right, for the lane level equipment, all right, and also we also have the standard for API data transfer to the and connect to the single platform, all right. So we have the standard for that, and also we also have the standard for the service level agreement for the private company who will provide the service of inflow to the road user. We also have the service level agreement in order to evaluate and access the performance of the private company also, all right? So that is our challenge, all right? And as I just mentioned earlier, the three key factors for the success story of inflow is that first we have to have the state-of-the-art technology, all right? So that's why we just, Dr. Agachai just mentioned about the equipment at the lane level, the infrastructure, and also the inflow system for the single platform, all right? And so also we have the audit system, inflow audit system, in order to double check the revenue, in order to check the number of transactions and so on, all right? So that's the first key factor, all right? We have to have the cutting edge state-of-the-art technology. And the second factor for this success story is the intercity collaboration, all right? Because in order to launch the new product that has a huge effect on the society, we have to have like the collaboration between the organization. We will talk about that later on. And also, as I just mentioned earlier, that for this inflow system, it is postpaid, all right? People can go and pass the toll gate and then come back to pay the toll fee within some certain amount of time. So we allow them to pay the toll fee within 7 days before penalty. All right, so that is a huge impact I will talk about later on, all right? So this is the comparison between the conventional toll collection system starting from MTC, manual toll collection. All right, so that's I just mentioned earlier that you have to pay the cash at the toll gate, all right, and then the gate open and then they just go, all right? And then we just developed to use M-Pass, Easy Pass, all right? To do that, it's like semi-automatic, all right? But we still have a lot of pain points. And then right now, we deploy the inflow on motorway number 9, all right? And as you can see that the flow rate is more than 2,000 vehicles per lane per hour, all right? So it's like the capacity is 5 times higher than manual toll collections, and also it can be compatible for any type of vehicle, 4-wheel vehicles, 6-wheel vehicle, and also more than 6-wheel vehicle, because the classification for motorway class depends on the number of wheels. That's another challenge, because we have to have the system that can verify the number of wheels, not the volume, not the length, or not the number of axles, all right? So the system has to be able to identify the numbers of views, all right? So that's another challenge for using this type of tolling system, all right? And we got various type of payment channel, all right? You can pay any channel, like you can pay by credit card, pay by QR code, or you can go to the convenience store to pay for the toll fee. So this is what we are trying to do, is that because the idea of using inflow is that we design this system in order to provide the best convenience to fit the lifestyle of the road user, all right? So that's our idea, all right? So this is the technical about the inflow, all right? We use the video tolling, all right, and capture the license plate using the AI in order for the OCR, all right? And then we build the transaction to the road user, and then they pay the bill within time, all right, without any penalty, all right? So that's how we work, how it works for the journey of like inflow, okay? And after 2.5 years of operating inflow, all right, you can see that we can reduce the manual toll collection lane by 44%. And as you can see that for the multi-lane free flow, we don't have the booth anymore, all right? And then we can reduce the number of toll gate officer on M9 by 24%. But we don't have any policy to lay off the workers. So that is very important. So when the process change, the strategy is that we do not lay off the worker, but we do not hire more worker, all right? When they quit, we do not hire anymore. And another strategy is that we reskill and upskill and reposition the worker to do another job, all right? So that's our method in order to reorganize the structure of motorway, all right? So we can reduce the number of toll gate officer and then reposition to do other job, like for example, to do the point of sale, to do something like that, all right? So that's all to be the call center or like marketing, something like that. So we need to reskill them and reposition them to do another job, all right? And then we can reduce the labor cost by 36.18 million baht per year, all right? So this is the advantage of using inflow and also the lesson we learned from using inflow for 2.5 years, all right? And as you can see that one of the major concern is how we can apply the law enforcement, all right? Because for this system, for the inflow system, we allow the user to pass the toll gate first and then come back to pay for the toll fee within like some time, all right? Some certain times, all right? So what we can do is that we get the collaboration between the agencies. So we sign the MOU, and then we reform the traditional law and regulation to support free flow toll system and postpaid payment. And as you can see that these are the interagency collaborations. So as you can see that we collaborate with a lot of and get some help from every sector that we need to collaborate, all right? First, we need to check the personal data from the Department of Provincial Administration, all right? Once the user tries to register, we need to double check and cross-check the personal data from Provincial Administration Department. And also, we also need to verify the vehicle information with Department of Land Transport. All right, by doing that, we need to exchange the data with the Department of Land Transport so we can verify the vehicle information. All right, and for the law enforcement, all right, we also collaborate with Highway Police Division, all right, in order to enforce the user to trying to avoid to pay the bill. But actually, like you can see that after 2.5 years, all right, as Dr. Agachai said, the succession rate of payment is very high compared to other countries. You can see that for member, all right, the successful rate of payment is high up to 99%. All right, very high. And for non-member who just passed the inflow and come back to pay for the toll fee, the succession rate is like up to 90%, 97%, sorry, 97%, very high, all right? And as you can see that there is a policy in order to get 100% toll fee, we got the private company in order to subsidy, and then they have the task in order to get the revenue to all over 100%. So that is the private company job, all right? So this is also the economic values, All right, so you can see that once we evaluate, all right, you can see that this is the benefit of using M-Flow. You can see that we can improve the VOC, VOT, and also we can reduce the carbon emission, all right? So it also enhance the benefit according to environmental perspective, all right? And we can reduce the capital cost and operation costs, all right? So when we evaluate the benefit according to the economic indicator, all right? It's like, it's a 6.94, all right? It's a BC ratio, all right? And also, another interesting case is that it also help in case of like social welfare benefit. For example, like in case of emergency, for example, like an ambulance or police car, they can first register with M-Flow. And then they don't need to stop by at the toll gate and wait for like sign the contact and whatsoever, right? So it takes a lot of time. But using this M-Flow system, all right? So there is a hospital, get the requirement, just submit the requirement to motorway department, motorway division, and then they said like this is the ambulance for this hospital, all right? So in case of emergency, this ambulance can pass the toll gate very rapidly, all right? So that's another benefit of using M-Flow. They don't need to slow down, all right? So this is a statistical of the velocity and the flow rate after we open the M-Flow for more than 2.5 years. You can see that before operating M-Flow, you can see that the average speed of the vehicle passing through the toll gate is like 12 kilometers per hour, all right? And after we've been providing the service of M-Flow for more than 2.5 years, you can see the average speed increased by 180%. The total average speed of the 4 toll gate, Thap Chang 1, Thap Chang 2, Thanjaburi 1, Thanjaburi 2, you can see that it increased from 12 kilometers per hour to 36 and up to 40 kilometers per hour. All right, so people like for normal case, for example, like normal weekday and normal weekend, we don't have any problem of the traffic congestion anymore. But we still have some problem, slightly problem, in case of long holidays. For example, like if we got extra holiday, like 3 days, and like not regular motorway user pass these 4 toll gates. So then they are not confident, they don't sure how to use M-Flow. So they decided to wait in line of the manual toll collection. But for normal days, all right, weekend and weekday, right, we can effectively solve the traffic congestion for these 4 toll gates that we have been using M-Flow, all right? So you can see that also the number of flow rate also increased by 43%, all right? In another interesting story is that I would like to ask you about the number of members before we opened M-Flow 2.5 years ago. Like just imagine that February 2022, before we launched M-Flow, we are trying a lot. We're trying so hard to do advertisement, to PR, to convey, to get the attention of M-Flow using several channels, using influencer, using social media, and so on. All right? And then we just ask the road user, motorway user to register before we launch M-Flow. 3 months before we launch M-Flow. So can you guess how many members we got before we launched M-Flow? 30,000 members before we launched M-Flow. And on Valentine's Day, all right, on the night of Valentine's Day, 15th of February 2022, we launched M-Flow. And then it has a big impact on the motorway user. Why? Because it changed the process of their family, right? Because they have to actually before inflow they have to stop at the toll gate, pay for the toll fee. But once we open inflow, they just go pass by, all right? And then they don't know, they don't even recognize this is inflow lane, all right? And then 3 days later, when they got the penalty, then they start to advertise inflow for motorway free. All right, so that's the idea, because the celebrity, everybody just talk about inflow. That's why we get the attention, and that's the big impact. That's the big impact. All right, after they get the penalty, they do advertisement for every channel. TikTok, Twitter, YouTube, every channel. All right, so that's why we get the attention. So what we trying to do is that we are trying to explain, trying to attack, trying to try to go into the road user and try to explain what is inflow, what is the process of inflow, how you can use it, how you can pay for the toll fee, and what is the advantage of using inflow. And from that, there is also the policy from the Minister of Transport. He helped solve the problem using alleviate the problem using 2-month grace period without the penalty, and then try to educate, try to explain what is inflow. All right, so that's why we can pass that problem, because that is a big impact on the society. All right, so, and then after that, you can see that the first day when we operate inflow, we got only 30,000 members. And right now, you can see that we have more than 660,000 members who register for inflow. We have registered vehicle more than 770,000 vehicles registered for inflow. And you can see that the first day we operate inflow, you can see that, just imagine the number, right? Before inflow, we have the 70% of road users use manual toll collection, 70%, and 30% M-Pass, Easy Pass. All right? The first day, the user used inflow about 20%. All right? 2 years ago, 20%. And for the current scheme, the proportion of the motorway user for these 4 toll gates, you can see that the number of inflow user increased from 20% to right now 40% within 2.5 years. All right, so that's intriguing number. All right, 40% using inflow, 15% using M-Pass, Easy Pass, and about 40% using manual toll collection. So that is the current picture right now for the road user who select the method of the toll collection right now. All right. So another thing is that we are trying to enhance, all right, and then try to invite everybody to register for inflow member. We are trying to get the free tip who register for inflow, get the discount in case of inflow user, and also we also try to develop more channel. One tool that we use is that we also, after we launch, because the first 2 methods to register for inflow is to register by the application or register through the World Wide Web. All right. And another tool that we apply is that we use the LINE official account. That is another tool that we can reach and gain a lot of friends, because right now for LINE official account inflow, we have more than 2 million friends. All right, so we can then communicate, we can get the registration through the LINE account, they get the billing, they can pay through the LINE official account also. So that's another channel that we are trying to improve in order to gain more inflow member, all right? So this is our future plan after we already deployed the inflow system to motorway number 9. So for the future motorway and also concessionaire, we are trying to use inflow more and more in order to cover, for example, next year we are trying to open inflow for motorway number 7, motorway number 6, motorway number 81, and the following year we are trying to open the new motorway, which also include the inflow tolling system. All right, so this is the overall future plan, all right, for the next 2 to 5 years, right? So what we are trying to do is that we are trying to expand the inflow in order to cover all of the future motorways. All right, so that would be all for my presentation, and thank you for your attention. If you have any question, please feel free. All right, thank you.
Dr. Thongkang is also the president of ITS Thailand. Today, he will be sharing the integration of intelligent transport system for smart highways. Let's welcome Dr. Thongkang.
Thank you so much, Lenna, for your introduction. Good morning, everyone. My name is Thongkang Thong. First of all, I would like to thank you, FETC, and also DOH for inviting me as a guest speaker today. It's very honored to be at the important workshop today. So today, I just want to introduce the ITS, or Intelligent Transportation System, for the smart highway especially. So some of you might not have heard about the ITS before. The ITS actually is with the definition of the implementing the new technology to the transportation and also the logistics. Today's presentation, I will cover 4 topics. One is I would like to take you to the world and look at how the other country implement the ITS into their countries. The second one, I would like to talk about the ATMS, which is stand for the Advanced Traffic Management System. And the third one, so I will try to dig inside for the ETC. Some of you might have heard from the 2 speakers previously. And also the congestion pricing, which is very popular now in Thailand, that many people, especially the government, try to talk about. And the last one, how could we integrating the ITS with the emerging technologies to Thailand and to the other country in the future. So let's look at the overview of the ITS implementations. So actually, the ITS try to implement not only in the developed country, but also developing countries too. So they try to tackle the urbanization which is expanding every day, and also the traffic problems, as well as the sustainability challenge that many people concerned about the environment. So they try to do the comparative analysis for the technologies and approaches used by many countries to enhance the traffic management, safety, and efficiency, for examples. So we also have some question that how each country able to help the other countries. So the laws of international standards become really important nowadays. Let me take you to European country first. So first of all, they create the unified frameworks. They call it the ITS action plan. So that they try to create the system across the member states all over the European countries. And this system, they call it a CITS platform. The C stands for the cooperatives, which is able to help and also enhance the traffic flow and safety. So you can see that the European country is not only try to focus on the private vehicles. They also try to help the public transportation and promote transport with sustainable and efficiency. This is another example that European countries try to do. They call it the C loads. They separate into the short lane and the long lane categories. And you can see that for the short lane that they have about 20,000 kilometers. And for the long lanes, they put into the 100 kilometers for the European loads. In the US, actually, I use the USA, which is represent in the North America. So they call the national ITS architecture. So they try to support the traffic management and toll correction for the ITS system. And also they also use the ITS for the ICM, which is stand for the Integrated Corridor Management. They try to help the traffic flow also, and also reduce the travel time in the city, especially the big one. For example, like Dallas and San Diego. In Thailand, in Asia, or the Asia Pacific, if you travel to Japan, you might have heard the name of WICS, VICS, is lead of ITS or implementation that try to provide the real-time traffic and also the advanced ITS system that we call V2V, vehicle to vehicle, and also vehicle to infrastructure communication. In South Korea, they have some smart thing to implement into the highway too. They call the high pass that try to integrate ITS with the smart city techs to optimize the traffic flow and also the tolling system. And another good example is the ETC system that implement in Taiwan. The Taiwan ETC system is a regional model to reduce the congestion and also the emissions across the whole country. This is the good picture of the ETC implementation in Taiwan. As I mentioned earlier, we need something that we can work together as a guidance. So the laws of international standard and the framework become really important. So the ISO, IEEE, and ETSI become really important when we talk about the cross-border. So the cross-border cooperation, for example, ISO 14813 enable the cross-border cooperation and also the technology adoption between country and country, between city and city too. So the second topic that I would like to discuss today is about the ATMS. So you can see that every city, especially the urbans, have a lot of population that, and also the vehicle that increase every day. So they have a demand for the advanced traffic management solution. So ATMS become a really innovative solution. So for example, adaptive signal control optimization, traffic flow, and also the safety. So you can see that many cities already implement the ATMS into their city, such as the Singapore, London, and also the LA. This is the picture of ATMS implementation in the US. Some of you might guess that where it is, probably in the slide presentation previously, but actually it's in Nevada in the US. So in Singapore, they also have the model for integrated traffic management into the country. For example, the EMAS, which stands for the Expressway Monitoring and Advisory System. So this creates the real-time expressway monitoring and also help to quick incident response, as well as reduce the congestion to the the expressway system. And the second one, which is really new, is called the Green Link Determined System, or GRI. So this kind of system is adaptive traffic signals that optimize the flow and also the prioritize traffic transport, as well as they're able to cut the travel time on the road. And the last one, some of you might have heard before that the ERP, or electronic road pricings, is create the dynamic and tolling management demand, which is reduced during the peak hour congestion that Singapore claimed that they're able to operate effectively and efficiently too. This is the photo of the ERP that implement in Singapore today. In London, they also have the technology, the ITS implement into the transportation. The first one is LSTC, is the real-time traffic monitoring and also the signal control. This technology, they're using CCTV to do some analysis and monitoring as well. And the second one, London also have something called congestion charging schemes that they try to reduce the central traffic and also the emission to the entry fees into the city. And the last one is called Scoot. Scoot is adaptive signals that able to improve the traffic flow at the important intersections. At the LA, they have the three technology that implement into the city. One is the ATSAC system. It's also the real-time monitoring and adaptive signals. And regarding to the state of the US, it's really kind of big. So they try to implement, they call ICM, Integrated Corridor Management, that coordinate the signal and lamp meters to optimize the traffic flow and also reduce the delays. Lastly, and they also try to do the predictive analytics that use the old data and also the real-time data to anticipate and mitigate congestion before it's happened. So we can see that we can understand the lesson learned from the other cities, from the integration and coordination with the ATMS. And also every city is like, it need the tailored solution. So that means each city also need their own solution to solve their problem. So, and the last one, they also need the ongoing upgrade. So you can see that the technology goes so fast, and probably on regularly update technology is really important. The third topic I would like to discuss is about electronic toll correction and also the congestion pricing. And many countries already have the good practice on this one. For example, the US or Norway or Singapore, as well as Taiwan, that I would like to highlight in this session. So we can see that there are a lot of benefits that beyond the traffic management. For example, the traffic improvement, and we are able to generate the government able to generate the revenues, and also the city able to reduce the emission that will help create the strong environmental sustainability. So we have the technologies for the ETC, for example, like a RFID tolling that used in the US, for example, the Easy Pass, and also in Singapore, for example, like a ERP that I just mentioned earlier. Now we also have the new kind of technology. It's not really new, but it's expanding a lot by using the satellites. Now they try to put the GPS into the car, and probably in the future they will chart each car using the satellite platform. And the last one, they're using the ANPR system, which is the camera-based license plate recognition. You can see that international example is like London and Stockholm congestion pricings. So we can see that there are also impacts on the traffic flow and congestion management for the ETC and congestion pricing, even though they're able to minimize delay, manage peak traffic, and encourage of peak travels. But they also facing the problem with the social impact as well. In Singapore ERP system, they're able to help to cut the peak traffic, and they also put some fund into the public transport improvement too. And for the London congestion chart, that they're using the ANPR system, that they claim that they're able to reduce the traffic by 30%. And they said that they also able to lower emission and help to boost the public transport use, because many people, especially the private drivers, don't want to pay extra more into the city, and it will help to boost increase of the people use for the public. So the government also able to help, increase of the revenue and also the economic impact using the ETC and congestion charging. For example, the revenue generation, that this revenue able to fund for the reinvest in the infrastructure and also the other public transit. For the Norway, they have they call the toll ring system. This kind of system they're using RFID, that they use the revenue to fund the transport projects, and they're able to balance the revenue with reducing congestion. And in the California is another good example that too, that they're also using the RFID. This is the good picture of the toll collection in Norway, that you can see on the right hand side that they create two categories between a four-wheel vehicle and also the big vehicle that have the weight more than 3.5 tons. The ETC and the road charging also help the environmental sustainability and social equities by improve, for example, the air quality. Stockholm's congestion tax is a good example that able to reduce the traffic and emission, and with the extensions for the fairness. And in Italy, they also have the area they call the Milan Area C, that they charge by emission, and they using this revenue to fund the eco-friendly transport too. This is the photo of Area C Milan, that you can see they create the circle, at least you can see from here about 3 circles. The last one that I just want to mention, that how we going to integrate the ITS with the emerging technologies, and how the future of the road transport will happen. First, you can see that the ITS is developed every day. We going to have the new vehicle, not the EV or electric vehicle in the future, but we going to have the we call AV or autonomous vehicle. And the upcoming technology, I think everybody already uses, is a 5G technology. But I think we're going to have another level, which is 5G, and also the advanced one in the near future is a 6G communication. And the last one, the IoT. IoT stands for the Internet of Things. With these 3 of these, able to transform the road transportation tremendously. So the integration challenge that I think is really important too when many people talk about the cybersecurity. regarding to we try to apply the technology into our infrastructure and also our private vehicle too. So we can see that a lot of risks that we might need to manage, that is from the bad people, which is cyber security protection system is a need probably in the near future too. The second one, the interoperability between organization and agency, and also public and private, and also agency and also people and also the user too is really important. The last one is a regulatory need. This is really important as well, because it's from the government and it's from the stakeholder that able to create the regulation and laws for the IT. So this is my last slide. So I would like to talk about a little bit on the future trends and innovation in the ITS to the smart highways. So probably we might need to recognize the AI. Some of you might already use this kind of AI with your phones that able to capture your face and recognize your face too. Probably we might need to enhance the traffic prediction and the signal optimization, and also try to boost autonomous vehicle navigation using this kind of technology. The second one, the blockchain technology is also really important, that able to provide the secure, decentralized data management, and also help to create the safe data for sharing with within the organization and between the organization as well in the ITS. And the last one, cyber security that I mentioned earlier, is the future of ITS requires to protect against of increasing cyber threats due to the greater interconnectivity. That's all for my presentation. Thank you for your attention.
Lastly, we have Chen, Managing Director of FETC International Thailand. Kenny has more than 20 years of experience in the tolling industry, and today he will be presenting on AI 5G, driving the future smart mobility solutions for green and smart cities. Let's welcome Kenny.
Thank you everyone to come in to join this session, and I'm the last speaker. You know that it's really a lot of stress to speak after 4 doctors. So, but I will try my best. I will try to explain more detail. I will try to share a story, not just saying something that you are not related to you. So, ผมพูดภาษาไทยได้นิดหน่อย So I prepare a video which is in Thai to share with you what we are doing and what we have done before. When they are preparing the Thai video, let me share with you that FETC, we was a BOT operator who is collecting the national highways tolling in Taiwan. It's a BOT project. We get a BOT contract in 2004. And after we successfully deploy the multi-lane free flow to the whole country, we established FETC International in 2017, so that we want to introduce our solutions and also, of course, our experiences to share with all the friends in different countries. And in 2020, we established the FETC Thailand so that we could build up an ASEAN hub in Thailand, because Thailand is the central for the whole ASEAN countries. We want to have a more convenient and more efficient support to our customers. So the story about the Taiwan ETC is that in the first beginning, we faced the same situation just like what Dr. Thanasak mentioned. In the first few years, we introduced the IROBU with 2 pieces of a solution, which is the iCHE car. And the penetration rate is just stuck in the 42%, around 42%. We could not get more customers, and we faced a lot of challenges. So after we evaluate different technology, we decide to introduce the RFID into Taiwan's national highway for tolling. For the single lane free flow stage, we introduced the RFID, and it's already single lane free flow. So we don't have the issue about the barrier. But the issue we face is that the penetration rate with the IROB could not grow. So the RFID is the way that we give out for free, so that the penetration rate grows from 0 to 90% in 18 months. So it's a good reference for you that if we could provide this kind of free RFID or free onboard unit to the public, that will help a lot for the penetration. But all of us knows that it's cost. It's everything about the cost. The OBU cost is higher than the RFID, so we could not do that before. And because of this decision, we replaced all the old systems. It's $1 billion of lesson learned, because all the equipments we replaced, all the new equipment, all the RFIDs we give out, it costs a lot of money. But the vision of our country is that we want to provide a more convenient tolling services and more efficient way to collect the toll for our country. Of course, we have some contract obligation we want to fulfill. Okay, so after the single lane free flow, we start to introduce the multi-lane free flow into the whole country. The multi-lane free flow in Taiwan, we just roll out in 3 days. The whole country will change from a single lane free flow to multi-lane free flow. And I think it's quite a successful deployment, because the whole country, we changed that, and the multi-lane free flow reduced a lot of congestion before the toll plaza. And after the multi-lane free flow deployment, we also start from introducing different derivative business that using this digital infrastructure. So we build this digital infrastructure for the whole Taiwan, and then we have a lot of applications built on top of these foundations. Just like the parking, we already have 2,000 parking lots in Taiwan, which every driver could just drive in and drive out without any barrier, stop lane, and they even don't need to pay. They could just drive out, because all the money will be deducted from their account or the credit card they registered in our system. And besides of these derivative business and applications from different applications that we use in Taiwan, we still keep improving ourselves. Just like what Dr. Thanasak mentioned, we are open to all the technology. Technology will evolve. So now maybe popular, now RFID is maybe the best solution for current tolling environment. But how about next generation? So we already have a POC for the AI 5G integration for the tolling system. We follow the worldwide standard, worldwide standard for tolling using the CV2X protocol. So you found it similar, right? You see that in previous speaker's slide. This is the before and after comparison. Before we roll out the multi-lane free flow, the toll plaza, in front of toll plaza, it's just congested, just like the above picture. And after we introduce the multi-lane free flow, the tollway is just like the upper image, so it's more efficient and no more congestions. So since we start to introduce our solutions to different countries, this is our experiences in different countries, including Bosnia and Herzegovina, Kazakhstan, Vietnam, Philippines, Malaysia, of course, India and Thailand here. Okay, so after we go global, we got some recognition from different organizations or committees. So seeing is believing, so that we could see this is the pictures. We are there. So this is the awards we got. So in Thailand, what we did, for just like the Dr. Thanasak mentioned, the M-flow system in M9, the first multi-lane free flow solution is developed and deployed by FETC. So we introduced the front-end system into M9, and so we help to. Of course, it's our honor that DOH give us this opportunity to deploy it. So the project is that for M6 and M81, this will be our following project. We already developed and work with the BGSR consortium. BGSR is BTS, Golf, Sinothai, and Raj. We work with this big consortium. We want to deploy the first smart highway, integrate the tolling and ATMS together so that we could build up a real smart highway in Thailand. In our solution, we are really, we do a lot to improve our solution and technologies. Just like we do the AI AMPR in Taiwan, we build an engine, and now we try to training our engines to adapt with the very complex Thailand license plate. As you see in Dr. Agachai's slide, so Thailand license plate is not easy to recognize because of Thai alphabet and also the province. But according to, based on our training and keep improving, we already proved that our Thailand license plate AI recognition engine, the accuracy rate could reach to 98.22%. And we're still improving it. The newer version of our engine, the accuracy rate is even higher. So if you want to try it, just let us know. We could do the POC and testing with you. So the AI AVC is also another one that we're trying to do. We're trying to use in the AI for the vehicle classification. So for this AI AVC, of course, we passed the standard of 95% of accuracy rate, but the actual number is even higher. And as I mentioned, that this digital foundation, digital infrastructure foundation could help to build a lot of applications. Weigh emotion is another good example that could reduce the congestion on the highway and on the main line. So we build this kind of pre-filtering solution so that we could filter the overweight vehicle and indicate them to go into the static weigh station. But if the vehicle or truck is not overweight, they could just non-stop. They don't need to slow down. They just go follow the flow, and without any, they don't need to stop to go into the static weigh station. And this is another application that we developed for the whole highway operations. The highway operations that, just like in Thailand, in Taiwan we have earthquake, we have thunderstorms, we have a lot of this kind of environmental impacts. But we still need to keep a very, very high service level. But we still want to keep our engineer, our staff safe. So we developed this micro weather station. We integrate, we collect, we co-work with the Central Weather Bureau. So we integrate these different data to do the weather prediction. So we could know that is there any thunderstorm crossing or close to our gantries? And if there is no, if this is the scenario, we will not send our engineer to repair or replace the equipment on our gantries. But if it's just raining, but there is no thunderstorm here, then we could still send our engineer to replace some the broken components. Besides of this safety of our engineer, we also do the predictive maintenance for our equipments. All of our equipment is industry level outdoor equipment, but still there's nothing that will not ever broken, so we still need to replace it. but replace this kind of equipment will impact to the operation of the toll collection. It's not acceptable. So we trying to do the predictive maintenance using this micro weather station. We collect all the sensor data, including the humidity, including the PM 2.5, temperature and vibration, and so on. So this is how we keep improving our operation to a more successful. So besides of the weigh motion and the weather station, of course, tolling as a foundation for more public services is what we are trying to do. So we try to synergize the digital infrastructure for more government applications. What about that is related to the traffic management for the ramp control. We integrate with all these data and so that we could do a smart ramp control to control the traffic into the highway. And also we co-work with the police bureau for the enforcement of the blacklist vehicle for the criminal vehicles. And we also work with the tax bureau for the tax recovering for the vehicle tax. And also we work with the Environment Protection Bureau for the green zone protections. So of course, we have some applications to control and monitor the heavy vehicle fleet management. Besides of government applications, we also co-work with the private sectors. We introduce these digital foundations to different applications and co-work with private sector, including the parking. As I mentioned, we have worked with the parking lot operators for more than 2,000 parking lots in Taiwan, so that the drivers or our members don't need to pay the parking fee in front of the kiosk or pay to the parking fee managers. But also we integrate with the department store so that all the expense we could reward to their parking, we could redeem their parking fees. And beside of this, just like the regulation in Taiwan is also just like in Thailand. The electricity could not be sold by individual private company. The electricity could only be sold by the authorized company. So how could we do the EV charging? How could we charge the charging fee for the EV owners? So we integrate this EV charging as a service fee into the parking fee so that we could do this business in Taiwan. I think we could also introduce this practice in Thailand also. So talking about the future, the 5G RFID dual mode ETC we did in Taiwan is that we integrate the 5G CV2X standard. There's a message set, especially for tolling. This is a trend in the future. We don't know that if it will come out or it will be successful, but we already ready for that because it's already proven. The onboard unit, CV2X ready onboard unit is using the PC5 protocol, and the speed we test in Taiwan is over 190 kilometers per hour. We still collect the toll. We still deduct the toll fee from the account and also send the successful message through the PC5 to the onboard unit. So why I keep saying that the smart highway as a digital infrastructure and a foundation for smart city. As you could see that it's not only a smart city, it's a smart nation. You will see there are different applications, no matter in the public sector or the private sector. We could adopt this, we could use these foundations to develop different kinds of applications. It will help the whole society to have a better living and better efficiency for all the vehicle and drivers. Not to mention that smart nations, but also we just take across to different countries in the world. So how do they do RFID tolling, and how do they utilize this digital infrastructure foundation for different applications? Just give you a short example, like Malaysia. Malaysia is introducing the vehicle entry permit. They already implement it using the RFID from Malaysia and Singapore. So Singapore vehicle go into the Malaysia, they have to pay the vehicle entry permit. they are also trying to implement this in between the border of Malaysia and Thailand. So we are also participating in this project. So maybe one day, if we want to collect the entry permit from Malaysia vehicle, we could also share you the reference and our solutions for vehicle entry permit. And besides of Malaysia, there are a lot of countries link the RFID tolling with the DOT information, the vehicle registration information. Just like Sri Lanka, Philippines, they already, and even Myanmar, they are planning to do the vehicle registration together with the RFID and tolling applications. So when we mention all these different references from different countries, so what we are trying to do, what is the future that we are proceeding? Actually, it's multi-lane free flow. We want to use this to use this foundation as road user charging and congestion pricing. Just like New Zealand, Singapore, and USA, they are doing this. This could be our reference. It's not only for highway tolling or motorway tolling. We could also do the congestion tolling using this digital infrastructure and digital infrastructure foundations. So, just like the previous speaker mentioned, it's not just a digitalization, it's a digital transformation for the whole country, for the whole tolling services. We transform the legacy tolling services into a digital infrastructure foundation for a smart nation. This is the value that multi-lane free flow could bring to the whole society. I don't want to keep mention the ticket saving and so on, because the previous speaker already, everyone knows that no matter the paper saving, the carbon emission reduction, even the gasoline saving. But they didn't mention one thing. What is that? About this reduce of travel times. Just based on the numbers we have before, Dr. Tana Sak mentioned that it's around 600,000 transactions per day. If we add the expressway from EZEC, it's around 1.8 million transactions. We just calculate, we just give a small number like just 2 million transactions, 2 million trips per day. So if multi-lane free flow could help each vehicle in average to reduce 10 minutes of traveling or congestion time. So how much time we save for the whole society per day? It's, for Thailand example, it's more than 38 years. Every day we save 38 years. In Taiwan, the number is that every day, the highway, we save 42 years for the whole society. In Thailand, it's 38 years. If you just times the minimum wage, so how much is that? How much money is saving from the multi-lane free flow? It's a lot of money. It's a very big contribution to the whole society. But also, we think about this. The time saving is not only saving the money. You could use the time to have a very good dinner, to enjoy the time with your family and friends. It's priceless. It's priceless. So please, we could help each other. We could encourage everyone to utilize the M-Flow more, to register the M-Flow. And we also want to encourage that the whole society should continue this policy and this strategy. We introduce the M-Flow into all the highway and expressway. It will help the society, it will help this country to be a smart nation. So I don't know if they are ready for the video. So I think the time already runs out, so we will play the video. But if you have time, please join us to see the video. It's ready in Thai. And if you don't have time, you could also go to our booth. We have a big TV there. We could also show you the video. It's in Thai. So thank you very much for everyone to coming here, and thank you very much for all the speakers. It's my pleasure to have this workshop, to host this workshop together with you. Thank you very much. Thank you. Thank you. Sawadee krap.
Thank you, everyone.